All right, this is a video on the extra examples from section 3.3, which is over linear equations, how to write the equations and how to graph linear equations. So this first one says find the slope of a line that runs through the given points. So we're using our slope formula, y2 minus y1 over x2 minus x1. Label your first ordered pair x1, y1. Label your second ordered pair x2, y2. So the slope of this first one would be 6 minus negative 1 on top over 5 minus 5. So that's going to be 7 over 0. Now we cannot divide by 0, so this actually is undefined. So that would be a vertical line if we were to plot those points. Excuse me. x1, y1 for the second one, x2, y2 for the second ordered pair in B. And if we do our slope formula, this would be negative 3 minus negative 1, which would be plus plus, over negative 6 minus 4. So that's negative 2 over negative 10. Negative over negative is positive, and we need to reduce the 2 over 10. It's 1 over 5. So you have to always reduce your fractions. We did C in class, so let's move on to the next part. We did the graphs. So we're going to be wanting to write equations. Remember that to find the equations of lines, we need to have a slope and we need to have a point. If we're dealing with parallel or perpendicular lines, we need to know the slope of the line we're trying to be parallel or perpendicular to. So if we have a slope and if we have a point, we can use point slope formula. Just to remind you of what that is. It's y minus y1 equals m parentheses x minus x1. And that is a formula that allows us to put in a point and a slope that we know from our linear equation, and then we solve it for either y equals mx plus b, which is slope-intercept, or we put it in general form, which is ax plus by equals c. So y equals mx plus b, we said was called slope-intercept, and ax plus by equals c is general. A lot of textbooks refer to that as standard form. So the directions for example 3, we're writing everything in this group in general form. So the second form here. Now this first one says if our point is negative 4, 2, and we want to be parallel to the x-axis. Well, if you think about where the x-axis is, it's this horizontal line. To be parallel, you have to be another horizontal line. So here's the point, negative 4, 2, just to kind of give you a reference. If we want to be parallel to this, we have to be parallel to the x-axis, we have to be a horizontal line. Horizontal lines are always y equals a number. So the number here that we are is the height, so y equals 2. To be perpendicular to the x-axis, we have to be vertical. So vertical lines are always x equals a number. So that would be x equals the x-coordinate, which is negative 4. So this is a special case. If they just tell you to be parallel or perpendicular to the axes, you're talking about either horizontal or vertical. For B, they gave us a point and they gave us a slope. So this is my x1, y1, and this is my m. So I plug it into the formula, y minus y1 equals m parentheses x minus x1. This would be y plus 2 equals 5x minus 0, so we don't have to write that because we'd multiply 5 times 0 and we still get 0. And if we want this to be in general form, we need x and y to be on the same side. So you could subtract the y over. So that would be 5x minus y. And typically we'd want that to look like ax plus by equals c, so we can just rewrite it where we flip the entire thing. So there's my general form for that one. Okay, we did C in class, so let's talk about D. In D, we want this to be our point on our new line. We want it to be parallel, which means it has the same slope, to a given line. Now, to be able to talk about having parallel lines, you have to know the slope of the original line. So our first step is to find the old slope. So we need to solve that for y. So that would be subtract x over, divide everything by 3. So that's negative 1/3 x plus 1/3. So my old slope is negative 1/3. It's the part in front of x. To be parallel, we got to keep that the same. So same slope or new slope is still going to be negative 1/3. Your final step kind of goes with this very first part they gave you. You want to use this point and your new slope to get your point slope formula. So y minus 5 equals negative 1/3 x minus negative 3, which will be plus plus. I could multiply the 3 over to the other side, or I can distribute it here because this time 3 is divisible by 3. So I'm just going to go ahead and show a case where I distribute it. So that'd be negative 1/3 x. This would be negative 3 divided by 3, so that's just going to be negative 1. And then I would add, we're putting this in general form, so I do want to add the 5 over. Which would be plus 4. We want to also add over the 1/3 x. Equals 4. And then general form can have no fractions. So if you ever get to this point and you have fractions involved, to put it in general, you need to clear out those fractions. So we're going to times everything by that 3 in the bottom. So this would become just x plus 3y equals 12. That would be the general form for that equation. Okay, example 4 asks us to put all of our final answers into slope-intercept form instead of general form. So our final answer should look like this. And we have this x-intercept of negative 5, so we can write that as an ordered pair. A y-intercept of negative 1, so we'll write that as an ordered pair. If you have 2 points, you can use them to find your slope. So that would be negative 1 minus 0 over 0 minus negative 5. So that's negative 1 over 5. And then we already know the y-intercept. Remember, y-intercept is b. So if you already know it, you can just write your equations. This is negative 1/5 x minus 1, because the y-intercept is negative 1. I could get the same result by plugging it into point slope, but if you've already got the y-intercept, you already know your b. Okay, so let's look at the second one here. So we're doing the slope of this would be 7 minus 1 over 3 minus negative 2. So that's 6 over 5. And I'm going to use this point as the one I plug in. So y minus 7 equals 6 over 5 times x minus 3. Here's a good time to try to clear out that fraction since it won't multiply nicely. If you multiply both sides by 5, it clears out the denominator on the right side. We have to distribute this 5, but we'll also have to distribute this 6. And then we will subtract the 6x over to be on this. Oh no, sorry, we're not doing general form anymore. You get into a habit. We're doing slope-intercept, so we want to get y by itself. So we're going to add 35 over. So 35 minus 18, that would be 17. And it is positive because 35 is bigger than 18. And then we divide everything by 5. And those are as reduced as they're going to get. So as long as you can find a slope and a point, you can use point slope to get the equation that you need. So let's look at some other examples that I have in this packet. Now this one's a special case. I want to highlight 2 words here, perpendicular bisector. This is not just finding the equation of a line that's perpendicular, it's finding the equation for the perpendicular bisector. Perpendicular, remember, means that the slope is the opposite reciprocal of the other equation. Bisector means you have to go through a midpoint. That's the crucial part there. So bisector means midpoint. So we're going to find the slope of this first so we can get a perpendicular slope. So 10 minus 2 over negative 2 minus 4. My old slope is going to be 8 over negative 6, which reduces down to negative 4 over 3. My perpendicular or new slope is going to then be positive 3 over 4. Now I do not get to use either one of these points when I go to do point slope because I have to cross through the bisector. So I also need a midpoint. To find the midpoint, remember we add our x's, cut them in half. We add our y's, we cut them in half. This would be 2 over 2 and 12 over 2, so this reduces to 1 comma 6. So this is the point we use, and this is the slope we use. So y minus 6 equals 3/4 x minus 1. We multiply both sides by 4 to get rid of this denominator. So that would then be 3x minus 3. It does want general form, so we need to get x's and y's on the same side. So subtract the 3x over. So that would be negative 3x plus 4y. Add the 24 over to the negative 3. That would be positive 21. And then because we don't like our leading coefficient to be negative, we divide everything by negative 1. So my final answer is 3x minus 4y equals negative 21. And that's my general form. So this equation is actually the perpendicular bisector of this segment that we were given. Okay, for 6, we want to graph these using slope-intercept form, so we have to get it in the correct form first. So for this one, I'm going to add the 4y over. Then I'll subtract the 7x. So we want to get it in mx plus b form. Divide everything by 4, and so y equals negative 7 over 4x minus 2. Remember, this is our y-intercept, and this is going to be my slope. And the way that's written, that is a slope that can either be gone as down because of the negative being on top and then right, or you can do a change on both of those and go up and left. That would be the opposite of that. So negative 2 is down here on the y-axis, and I actually think I'm going to do one of each. So go down 1, 2, 3, 4, 5, 6, 7, right 1, 2, 3, 4. And then I'll also go up 1, 2, 3, 4, 5, 6, 7, left 1, 2, 3, 4. Notice my 3 points are all in the same line together. And we do draw the arrows on there to say it's continuing on. If they ask you to find the slope in the y-intercept, that means there'll probably be a spot for you to write that on your test. So my slope is negative 7 over 4, and my y-intercept, remember, should be written as an ordered pair. So 0, negative 2. Okay, for b part, we need to solve again for y equals. So subtract over the x. Divide everything by negative 5. Be very careful here. That would be negative over negative, so that's positive 1/5 x, because the 5's on the bottom, and then plus 3. So my slope is 1/5. And my y-intercept is 0, 3. And I want to graph that. So 0, 3. So since this is 1 over 5, I can go up 1, right 1, 2, 3, 4, 5, because that's up for positive and right for positive. Or you can do a double negative, which is also a positive. So down 1 and then 1, 2, 3, 4, 5 to the left. And there's my line for that one. Okay, for 7, they want us to figure out the equation. If you have a vertical line, it is always going to be x equals a number. Remember, it crosses the x-axis. So wherever it crosses is the number. So x equals negative 2. That is our equation for that. For this one, we need a y-intercept and a slope. So it looks like our y-intercept is at 0 for y. So we're going to mark that as a point, and then we need to find another point that looks like it's good on the graph. I think 3, 4 was supposed to be a point. Now usually they'll give you some points there's actually a grid line where you can count them, but this is the point I meant for it to be. So go up 1, 2, 3, 4, and then right 1, 2, 3. So up 4, right 3 would be a slope of positive 4 over positive 3. So if we want to write the equation for that, that would be y equals 4/3 x. You don't really have to write plus 0. That would be a little bit of overkill, but that's what the b is. Okay, so let's look at another one. This one has a b of -2, and another point that was supposed to be on the graph was right here. So this is up 1 and then right 1, 2, 3, 4. So up 1 for rise, right 4. So that's a slope of +1/4. So this would be y equals 1/4 x minus 2. And then the last one where we're supposed to pick the information off, this has a b of 1. And then it goes up, let's see, I think this is the point right there. Yeah, -1/4 is the other point. So up 1, 2, 3, but left 1. So up 3, left 1. That's +3 over -1, which is -3. So I would write y equals -3x plus 1. So if you have a picture, you just need to find the y-intercept and then find another point on the graph and then count the rise and run to get the slope. Okay, the final problem in section 3.3 is a word problem. It says two variables are linearly related if y equals ax plus b, where a and b are the real numbers and a cannot equal 0. So typically these are things that are going to be applications where they give us two ordered pairs. So this one, you have to come up with the ordered pairs yourself, but they are in the problem. So a baby weighs 10 pounds at birth, and 3 years later the child's weight is 30 pounds. Assume that the childhood weight, W, in pounds is linearly related to the age, T. Whichever one they state last is usually like your X. Okay, and also notice they write W in terms of T. So we're actually thinking of T as the X value and W as the Y value. So in that regard, time, if a baby is just born, that would be 0 years old. And it would weigh 10 pounds when it was born. When the baby is 3 years old, the child weighs 30 pounds. So notice the information is just written in a sentence form. So we need to find the slope. So that would be 30 minus 10 over 3 minus 0. That's 20 over 3. And then this is the y-intercept because it is the b value. So this is W equals 20 over 3t plus the 10 pounds that the baby had at birth. So that's my formula for this child's weight in terms of age. What is W on the child's 6th birthday? So now they're saying plug in 6 for age. Okay, so this would be, that reduces, that's 2 times that, that's 40 plus 10. This says that the child would be expected to weigh 50 pounds. And you do have to remember to write the pounds, that's the unit. And then the last one says, at what age will the child weigh 70 pounds? So that's actually W. So 70 equals 20 over 3t plus 10. In this case, we would be solving for t, so we would subtract that over. And then the way to get rid of a fraction is to multiply by its reciprocal. So that just gives me t on the right side, and then 20 goes into 60 3 times. 3 times 3 is 9. And this is years because that's the age that they're measuring in. So that is the end of section 3.3.